Imagine a world where industrial automation systems are not only precise but also powerful and scalable. This is the promise of the latest advancement in motion control technology, a new, highly advanced servo drive. This innovation is set to revolutionize modern manufacturing processes by offering exceptional precision and power within a compact, scalable design. But here's the challenge: achieving this level of performance requires a deep understanding of the underlying mechanisms and parameters. And that's exactly what we're going to dive into. By the end of this deep dive, you'll grasp not only the what but also the how and why behind this groundbreaking technology. So, let's begin by understanding the core problem we're solving and why it's so critical. To truly grasp the power of predictive maintenance within our advanced servo drive, let's dive into the physics behind it. Imagine your system as a living organism, constantly sending out signals about its health. The embedded predictive maintenance system acts like a vigilant doctor, monitoring these signals in real time. It uses algorithms to analyze performance metrics such as temperature, vibration, and power consumption. When anomalies are detected, the system predicts potential failures before they occur. This proactive approach not only prevents costly downtimes but also extends the lifespan of your equipment. Remember, the key to this technology lies in its ability to learn and adapt over time, making it an invaluable asset in any modern manufacturing setup. Now, let's delve into the initial configuration and setup of this advanced servo drive. To begin, you'll need to access the configuration menu via the embedded systems interface. Set the communication protocol to CA open, as this ensures optimal data exchange rates and reliability. Next, configure the node ID to 12 for this specific drive, which helps in distinguishing it within a network of devices. Adjust the motor parameters, specifically the torque constant, to 0. 25 Nm/A for precise control. Don't forget to enable the predictive maintenance feature by setting the diagnostic interval to 100 milliseconds. This proactive monitoring will significantly enhance the system's reliability. Remember, the key to a successful setup lies in the meticulous adjustment of these parameters. Now, let's delve into the practical execution and code logic behind this advanced servo drive. The first step is configuring the drive parameters. Set the baud rate to 19,200 for optimal communication with legacy devices. Next, navigate to the Motion Control tab and enable the multi-axis sync feature. This ensures precise coordination across all axes. For predictive maintenance, access the Diagnostics menu and activate the real-time monitoring option. This will continuously assess the system's health. Remember, the key to seamless integration with existing automation systems lies in the compatibility settings. Ensure the PLC communication protocol is set to Modbus TCP for smooth data exchange. And here's a pro tip: always double-check the firmware version to guarantee you're operating with the latest updates and security patches. Now, let's delve into the optimization techniques and edge cases that can make a significant difference in your system's performance. First, consider the parameter tuning for your servo drive. Fine-tuning the PID settings can drastically reduce overshoot and settling time. For instance, set the proportional gain to 2. 5. Integral gain to 1. 2. And derivative gain to 0. 8. This configuration strikes a balance between responsiveness and stability. Additionally, pay attention to the deadband setting. A deadband of 50 micrometers can help filter out minor position fluctuations, leading to smoother operation. Another critical aspect is the update rate of your control loop. Aim for a rate of at least 1 kHz to ensure precise control. Lastly, don't overlook the importance of thermal management. Ensure your servo drive is adequately cooled, especially during high-load operations, to prevent thermal drift and maintain accuracy. These nuances, though subtle, can significantly enhance the overall performance and reliability of your motion control system. Navigating the world of advanced servo drives, you'll encounter common pitfalls that can hinder performance. One frequent issue is improper configuration of the communication parameters. Ensure your baud rate is set correctly. For most applications, 115,200 is optimal. Mismatched baud rates between the servo drive and the controller can lead to erratic behavior or complete communication failure. Another common challenge is overlooking the importance of firmware updates. Always keep your servo drive's firmware up to date to benefit from the latest bug fixes and feature enhancements. Additionally, pay close attention to the power supply. Inconsistent voltage can cause the servo drive to malfunction. Aim for a stable power source with minimal voltage fluctuation. Lastly, when integrating with existing systems, compatibility issues may arise. Thoroughly test the servo drive with your PLC or other automation components to identify and resolve any conflicts before full-scale implementation. Remember, meticulous attention to these details will ensure smooth operation and maximize the benefits of your advanced servo drive.